In this video, I'm going to recap graphing exponential functions, which is 6.2. So we're going to start by looking at this example 1 from our notes, which was f of x equals 2 to the x. Now, on your table, these are the x values that you're going to have almost every single time. -2, -1, 0, 1, and 2. And so to find your y values, you have two options. So the first thing you could do is wherever you see x, put your x value. So like if you just had a normal calculator, you would do 2 to the power of -2, and you get 0.25. You can then do -1, which you can see is 0.1, or 0.5. So then if we put x in as 0, so 2 to the 0, we get 1. So you can fill in your table that way. Another way is you have access to Desmos. You can use it to its full potential. So what I mean by that is you could type in f of x equals 2 to the power of, we do shift 6, so now we have the exponent 2 to the power of x. If you hit the settings here, you then hit the table that you want with the equation. So don't add a blank table. You're going to go to the settings, get the table from your equation, and then you would just copy it right on. Now the other nice thing about this is we can now see the points that you would graph. So you would graph these 1, 2, 3, 4, 5 points, exactly how they look on here, and you would create your curve. Now as we go to the left, you'll see that no matter how far to the left we go, it's not going to cross the x-axis. Now it almost looks like it's touching the x-axis, but if we zoom in, you can see that here's the x-axis. It's actually not touching, and it's never going to actually touch the x-axis no matter how far over you go. So no matter what you put in for x, your y value is not going to be 0 and your y value is not going to be negative. So that's where we get the asymptote, that imaginary line that the exponential is never crossing. Now, eventually your asymptote can change, but we're going to be sticking with really basic exponential functions, meaning our asymptote isn't going to change right now. Our asymptote is going to be that line y equals 0. So I just want to show you really quick, y equals 0, that purple line, that's the line, that's our asymptote. That's what our line is getting closer and closer and closer to constantly, okay? Now, we also have our domain and range. So domain is all the possible x values. So on this graph, we have 1 over 2 to the power of x. And our domain is going to be the same for all the exponential functions that we talk about. Domain is what can we put in for x? Well, there's no limitations. We can put whatever we want in for x. We're going to get a number out. So the domain is all real numbers. That's not changing for these exponential functions. Our range is what y values do we get out. Well, we already talked about the fact that y can't be 0, y can't be negative. It's all the y values greater than 0. So all of these y values right up here. So again, for our simple basic exponential functions, that's not changing. We have one more graph that we looked at, and so I'm going to really quickly type it in here, and I'm going to type it exactly how it looks. So I mentioned earlier that our x values are not changing on the graph, so you can see -2, -1, 0, 1, and 2, and then I had an extra spot here. Really, technically any x value would work, but these are the x values that are going to give us a good picture of what our exponential looks like. So I'm going to hit the settings, I'm going to get my table, and you can see those y values. So when you are plotting your points, I want you to have the points from your table. So I don't just want some random curve. I want to see those points on your graph. And so the nice thing about looking at Desmos is we can see once again it's getting closer and closer and closer to that x-axis. So we again have an asymptote of y equals 0. Y-intercept, there is where the curve is crossing the y-axis, is your y-intercept, and it's always going to be that very first number in front of the parentheses. So it's the number that doesn't have the exponent of x. So like on these examples, there wasn't a number. So there would be imaginary 1 times 2 to the x, and our y-intercept was 1. And the nice thing about Desmos is you can always find it there as well, but with exponential functions, the number that doesn't have the x is your y-intercept, the number that does have the x is what you're multiplying by, and I'll talk about that more in the next video.